Yeah, so this is a question from GATE 2024, and the question is in the given circuit, the current Ix is, that also Ix is in milliampere. So this is the circuit, and we need to find what's the value of Ix here. Okay, so let us analyze here. So we have a 5 milliampere current source, a 2 milliampere current source here, and there is a dependent source, that is 1000 I naught, where I naught is the current flowing through this 1 kilo ohm resistor. Okay, so to analyze this, let us assume these two nodes, with this node having the voltage V1 and this node having the voltage V2. Okay, so which means the dependent source 1000 I naught, which is the voltage between these two nodes, right? This is equal to V2 minus V1 from circuit. Okay, yeah. Now we'll see the current source given. So here I have 5 milliampere current, and from that I naught is flowing in this path. Okay, so what is the current flowing in this path? This will be equal to 5 milli minus I naught, right? And at this node, the current flowing through this 1 kilo ohm is fixed, and that is equal to 2 milliampere. So what will be this current? This current will be equal to the current entering here, that is this current, that which is equal to 5 milli minus I naught. This minus the fixed current 2 milli, right? So minus 2 milli, which means this is 5 minus 2 is 3 milli. So 3 milli minus I naught. This is the current flowing through this 1K, which is actually the current Ix. So I can write Ix equal to 3 milli minus I naught. Right, so I just need to find what is the I naught here. Okay, so from the circuit, we will find both the voltage V2 and V1 in terms of I naught, and substitute in equation 1 to find the I naught. Okay, so here since the current I naught is flowing like this, so there will be a voltage drop like this across the resistance, which is equal to V1, right? So from the circuit, V1 I can write as the voltage across 1K, which is I naught into 1K, right? And similarly V2 is the voltage here, or the voltage across this resistor 1K, right? So voltage current is flowing from top to bottom, so there will be a voltage drop like this. So V2 I can write as the current Ix into 1K, or 3 milli minus I naught into 1K, right? So this is equation 2, equation 3. So I will substitute 2 and 3 in 1. Okay, so the equation 1 will be 1000 I naught equal to V2 is 3 milli minus I naught into 1K, minus V1 is 1K into I naught as per equation 2, right? So if I expand this, so 3 milli into 1K is 3 minus 1K I naught minus 1K I naught. So it is 3 minus 1K is actually 1000, right? So I can write this as 1000 I naught, 1000 I naught. So 2000 I naught, so 2000 I naught, right? And LHS is 1000 I naught. Okay, so I will bring this 2000 I naught to LHS, so I will have 3000 I naught equal to 3, or I naught is equal to 3 by 3000, or it's equal to 1 milliampere. So I naught here is 1 milli. So what is Ix? Ix is 3 milli minus I naught, or 3 milli minus 1 milli, that is 2 milliampere. So answer is to be written in milli, right? So Ix is equal to 2 milliampere. Yeah. So this is a question from GATE 2024. The question is for the two-port network shown below, the value of Y21 parameter in Siemens is. So the question is to find this Y parameter Y21. So first we will write the Y parameter equations. So this is the current input I1 and V1 at the input port, and I2 is the current through output port, and V2 is the voltage at the port 2, right? So the Y parameter equations are I1 equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. So the question is to find this value Y21, right? So we'll analyze here. So if we see this two-port network carefully, this node voltage is actually equal to V2, right? Okay, and this node voltage is V1. So from this we can directly find what is I1. So I1 is the current flowing through the 2 ohm resistor. So from this I1 is equal to V1 minus V2 by 2, or V1 by 2 minus V2 by 2, right? So this is the equation 1. And from the two-port network, one more thing is, like, the current I1 is flowing like this, and there is a current flow I2 like this. So what is this current? This current will be equal to I1 plus I2, right? And also what is this current in terms of voltages? So this node voltage is V2, and this node voltage is actually 8V1, right? Minus 8V1. So what is I1 plus I2 from this? I1 plus I2, the current flowing through this 4 ohm resistor, that is equal to voltage across 4 ohm, that is V2 minus the voltage here, so minus 8V1. Okay, so this is a dependent source, by, that is a voltage across 4, right? So by 4, that is the current. So this is equal to V2 by 4 plus 2V1. Okay. Now here I need this equation, right? And in this equation I have I2, V1 and V2. But here we have one more term I1. So what I will do, I will substitute 1 in this equation. So if say this is equation 2, I will substitute equation 1 in 2. So what I will get, instead of I1 I can write as V1 by 2 minus V2 by 2 plus I2 equal to V2 by 4 plus 2V1. So I can rearrange, I can take this term to RHS. So I2 will be equal to V2 by 4 plus 2V1 minus V1 by 2 plus V2 by 2. Right. So I will first club the terms related to V1. So 2V1 minus V1 by 2. So 4 minus 1, 3. So 3 by 2 V1. And plus this is V2 by 4 and V2 by 2. So it will be 2 plus 1, 3. So 3V2 by 4. Right. So this is I2. So here if I compare this equation, so equation A and this is equation B. So if I compare this Y21 is the coefficient of V1, right? So what is that? That is 3 by 2. So here this is Y21 and Y21 is equal to 3 by 2 or 1.5. That in Siemens. Okay, so the answer is 1.5 Siemens. So this is a question from GATE 2024. The question is, in the network shown below, the maximum power is to be transferred to the load RL. Okay, the value of RL is. So what should be the value of RL? Such a way that a maximum power should be transferred to the load. So what is it? So the value of RL should be equal to the Thevenin resistance RTH, right? Then if RL is equal to the Thevenin resistance RTH of the circuit, then we say that maximum power is transferred. So the question is to actually find what is RTH, and that value will be equal to RL. Okay, so how to find that? So to find the RTH, we have to short circuit the voltage sources, or if it is a current source, we will open circuit. So here only voltage source is there, so we will short circuit the voltage source, that also independent source, while dependent source we have to keep as such, right? So we will draw this circuit without the source. And this source is short circuited here. Okay, and this is the node where RL is connected. Okay, so this is 2 ohm, this is 3 ohm, this is 2, and this is Vx, and Vx is actually the voltage across this 3 ohm. Okay, so how to find the RTH? So RTH is the resistance seen from here. Okay, so to find RTH, since there is a dependent source here, what we will do? We will apply a voltage source. Okay, a dummy voltage source, we call it as Vs, and there is a current Is flowing from Vs. So what is RTH? RTH will be equal to Vs by Is. So I need to find what is Vs by Is. Okay, so for that we will analyze the circuit. So if we carefully see here, this node, the voltage across this is Vs, and which means the voltage across this node and this node is also Vs, right? Both are same. So what is the current flowing through this? This is the current, I will call it as I. This I is equal to the voltage across this node. This point to this node is actually Vs by the total resistance 2 plus 3, that is 5. Okay, so if this is the current flowing through 2 and 3, what is Vx here? Vx is the voltage across 3, that is current through 3 ohm into 3. So 3 by 5 Vs, that is the voltage across 3 ohm or Vx. Okay, and since this is the current flowing here, so what is the current flowing like this? This current is actually Is minus I, or Is minus Vs by 5, right? So I can again apply the KVL here, right? So across this is actually Vs, and this voltage is actually split across Vx plus minus and the voltage across this 2 ohm resistor. Okay, so that is the voltage across 2 is Is in minus I into 2. So from here, from circuit, I can write Vs as equal to the voltage across 2 ohm, that is 2 into Is minus I plus the voltage across this dependent source Vx. Here the current is current I is Vs by 5, right? So I will substitute that. So 2 into Is minus Vs by 5 plus Vx is 3 by 5 Vs. Okay, so 2Is minus 2 by 5 Vs plus 3 by 5 Vs, or 2Is minus minus 2 plus 3, that is 1, so plus 1 by 5 Vs. So I will bring 1 by 5 Vs to RHS, so it will be Vs minus 1 by 5 Vs equal to 2Is, or Vs into, so 5 minus 1 is 4, so 4 by 5 equal to 2Is, or Vs by Is from this equation is 5 by 4 into 2, so 2 times, so 5 by 2 is 2.5. So Vs by Is is actually RTH, right? So what is the question? What should be the value of RL? What should be the value of RL? RL should be equal to RTH, that is equal to 2.5 ohm, so that maximum power is transferred, right? So answer is 2.5 ohm. So this is a question from GATE 2024, and the question is, in the circuit given below, the switch S was kept open for a sufficiently long time and is closed at t equal to 0. The time constant in seconds of the circuit for t greater than 0 is. So question is, initially it was kept open and this switch is closed for t greater than 0, or t at t equal to 0, right? So we'll just draw that at t equal to or greater than 0, the circuit is 2 ohm, 4 ohm. So this switch is closed. Okay, 5 ampere, and this is 300. So what is the time constant? So we know the time constant of inductor is equal to L by the net resistance across the inductor R, right? L by R. So what is this R? This is the equivalent resistance across this node. Okay, across this resistance. So we can call it as like Thevenin resistance RTH. So how to find? We'll just find the Thevenin resistance across this two node. That's it. Okay, so I'll just redraw this circuit. So to find the Thevenin equivalent, we need to open circuit this current source, right? So and also I need to find the Thevenin resistance across this inductor. So this is the resistor 2. I have 4 ohm resistor here, 4 ohm, right? And this current source is open circuited. So what is RTH? I need to find. Okay, so what is RTH? So if we carefully see, this circuit is like, so if it is node 1 and node 2, node 1, node 2, okay. So from node 1 there is one resistor 2 ohm, and here at node 2 I have 2 resistor 4 ohms, right? So this is like this. So 2 ohm is kept in series with 4 ohm parallel, right? And this, since this is parallel, the effective resistance is actually 4 parallel 4, right? So that is equal to 2 ohm, 4 into 4 by 4 plus 4, right? So actually I have kept two resistance, right? 2 ohm resistance. So equivalent resistance RTH, I can write RTH as 2 plus 2 equal to 4 ohm. Okay, so what is the time constant tau? Tau is equal to L by RTH, and L here is 3 Henry, right? So 3 by the RTH is 4, so it is 0.75, right? 0.575 seconds. So answer is 0.75.